The composition of functions is the process of using the value of one function as the input value for a second function. If two functions are inverses, then the result will be x for both. So let's say we have two functions, f of x and g of x. We write the composition of functions as f g of x. Between the parentheses where we normally have x, our independent variable, we place the second function g of x. And this can also be written as this, f with the small circle between the g, f of g of x. And when they are inverse functions of each other, then both cases of f of g of x and g of f of x should result in x, the independent variable. Now, why is this? Let's say we place the independent variable x through an initial function, f of x, and we get x plus 7. Then the inverse function should undo this to give us the original value of x. And it should happen when we go the opposite way. If we place the independent variable through the inverse function first, the original function should undo the inverse, giving us our x again. So this is why f of g of x and g of f of x should both result in x if the two functions are inverses of each other. So let's walk through an example together. Determine if two functions are inverses. F of x is equal to x squared minus 3, and g of x is equal to the square root of x plus 3. So we'll first test f of g of x, and then we'll test g of f of x. So step 1, write the expression for the outer function, which would be the f function, x squared minus 3. And now we want to replace each x with the expression of the inner function. So where we normally have x, we have g of x. So we want to replace x with the square root of x plus 3. So we'll get the square root of x plus 3 squared. And then minus 3. And now we can evaluate the expression. So the square root of x plus 3 times the square root of x plus 3 would give us x plus 3 minus 3. And 3 minus 3 would give us 0, so that leaves us with just x. So f of g of x is equal to x, which is what we were looking for. And now we want to switch the g and the f functions so that we get g of f of x. And we want to see if this results in x as well. So step 5, we want to write the expression of the outer function, the g function, the square root of x plus 3. And now step 6, we want to replace each x with the expression of the inner function. So f of x will replace the x. So we have x squared minus 3 here, plus 3. And now we can evaluate this expression. Negative 3 and positive 3 cancel each other out, leaving us with the square root of x squared. And the square root of x squared is x. So since f of g of x and g of f of x both resulted in x, that lets us know that f of x and g of x are inverses. So that is how we go about using the composition of functions to determine if two functions are inverses. Let's now have you try a few practice questions. Determine if the functions are inverses. Question number 1. F of x is equal to 5x plus 2, and g of x is equal to x minus 2 over 5. Question number 2. H of x is equal to 7x minus 2, and j of x is equal to x over 7 plus 2. In question number 3, k of x is equal to 3x minus 4, and m of x is equal to x plus 4 over 3. Pause the video, answer these questions, and then press play when you are ready to begin. question number 1, we were given f of x is equal to 5x plus 2, and g of x is equal to x minus 2 over 5. So we'll first test f of g of x. So step 1, write the expression for the outer function, the f function. So that's 5x plus 2. And then step 2, replace each x with the expression of the inner function, g of x. So we'll replace this x here with x minus 2 over 5. And once we've done that, we can now evaluate this expression. This 5 and this 5 cancel each other out, leaving us with just x minus 2 plus 2. And negative 2 plus 2 cancel each other out, leaving us with just x. So we see that f of g of x does equal x. So now we can test g of f of x. We want to switch the f and g functions. And now we can test g of f of x. So step 5, write the expression of the outer function, the g function, which is x minus 2 over 5. And then step 6, we can replace each x with the expression of the inner function, the f function. So we replace this x here with 5x plus 2 minus 2. And now we can evaluate this fraction. Positive 2 and negative 2 cancel each other out, leaving us with 5x over 5. And 5 over 5 cancel each other out, leaving us with just x. So since f of g of x and g of f of x both resulted in x, that lets us know that f of x and g of x are inverses. So that is the answer to question number 1. Let's now have a look at question number 2. We were given h of x is equal to 7x minus 2, and j of x is equal to x over 7 plus 2. So we'll first test h of j of x to see if we get x as the result. So step 1, write the expression for the outer function, the h function, which is 7x minus 2. And then step 2, we want to replace each x with the inner expression, j of x. So we'll put x over 7 plus 2 here. And now step 3, we want to evaluate the expression. When we distribute this 7 to these two terms, this 7 and this 7 cancel each other out, leaving us with x. And 7 times 2 is 14, minus 2. 14 minus 2 is 12. So we get h of j of x is equal to x plus 12, and that does not equal x. So since we did not get x, that lets us know that h of x and j of x are not inverses. We do not need to test j of h of x, since h of j of x did not result in x. Let's now have a look at question number 3. We were given k of x is equal to 3x minus 4, and m of x is equal to x plus 4 over 3. So we'll test k of m of x first, and then if we need to, we'll test m of k of x second. So step 1, write the expression of the outer function, the k function, which is 3x minus 4. And then step 2, replace each x with the expression of the inner function, the m function. So we'll plug in x plus 4 over 3 for x here. And now, step 3, we can evaluate this expression. This 3 times this 3 will cancel each other out. 3 over 3 will give us 1, leaving us with just x plus 4 minus 4. And 4 minus 4 cancel each other out, leaving us with just x. So k of m of x does result in x. So now we can switch the k and m functions to test m of k of x. So step 5, write the expression of the outer function, the m function, which is x plus 4 over 3. And then step 6, replace each x with the expression of the inner function, The inner function is k of x. 3x minus 4 will be plugged in here, and then we'll have plus 4. And now we can evaluate the expression. Negative 4 plus 4 cancel each other out, leaving us with 3x over 3. 3 over 3 cancel each other out, leaving us with x. So since k of m of x resulted in x, and m of k of x resulted in x, that lets us know that k of x and m of x are inverses.